Alright, what's up everybody? My name is Sydney Nader and this is my final video for the ENME435 course, Remote Sensing, taught here at the University of Maryland, College Park. So today I have a facial detection smart doorbell algorithm for you guys. So it's a modification of the smart doorbell detection code that I previously posted about. So if you're interested, definitely hit up my YouTube page and it's the smart doorbell detection algorithm. Definitely has a lot of parallels compared to this code. So let's dive into this code. I'm going to give a brief overview of the code and then I'll give a demonstration and I'll talk about, good things, bad things, all that jazz. So we can see lines 4 through 8, just importing necessary packages. Lines 10 through 16, defining a region of interest. So in this case, these are the dimensions of the door in my bedroom if I want to monitor if a person walks in or not. And now you can see in lines 18, we're starting the main functions. So lines 20 through 25, just some initializations, defining the width, height of my camera, setting those based on, the dimensions of my laptop personally. And then we can see in lines 27, we have time.sleep, so that's just allowing the camera to initialize and adjust the lighting of the room before any data is collected. And then in lines 29 through 31, we can see some formalities. So when we save the video that we want to email to the, that we want to save to the computer system, we want it to save as an MP4. We want the output to be an MP4, so that explains the purpose of line 29. 30 and 31, just password and the email address that's being used to send the images to the user. And then we can see in line 33, this is just defining the location of the model and the prototext. Something super important to note, this is going to be used for facial detection to help make those detections, and it's very important that if you are to utilize this code, you need the deploy prototext.txt and the second file you see here, the cafe model. You need those both to be downloaded in the same path, so in the same file folder that you're running this code from. Alright, so now diving into the while loop, we're just grabbing current frame, finding the date and time, using the date time package, and then doing some more things with date and time. This is important when we're saving the image and videos as unique files, so they have unique names, and the best way to do that is to assign it to the time and date where that will always be unique. And then we can see in lines 43 through 46, we're constructing a blob. So this is, again, more stuff for the facial detection portion of the code. Something important to note is that a blob is a collection of images with the same spatial dimensions. So that's something that was really helping me understand functionality. And then with the line 45, we're just providing input data to the network, and line 46 is the actual detections that are being made once everything is passed through the face recognition model. So then lines 48 through 56 just focus on assigning different frames based on the iterations. So this allows us to have two different images to send to the user that are spaced out. So say I enter the frame, it'll take an image, and then frame 2 will now, maybe I'm over here, so it'll reflect that change to give the user two different images once someone has entered the region of interest. All right, and then lines 58 through 87, this is kind of the heart of the code. So we have this variable confidence. It's calculating the confidence that a face has been detected once the detections have been made in line 46. And then if the confidence is greater than 50%, so if the algorithm is more than 50% sure that a face has been detected, then it runs through and it'll say that the face has been detected, and then it'll send the user two images. We can see those being written in lines 63 and 64, and then this is just the record duration of the video that will be sent, so that's calculated based on frames per second. My computer is 30, and then outwrites the video. And then this is just this code is just running through and assigning frames and writing those frames based on the duration that I want the video to run. And then this is once the timer, I have a timer running that's incrementing by 1 each time, so 1 frame each time. Once the timer reaches the recorded duration that was calculated using frames and frames per second, it will release and send the video here. Okay, so Now I'm going to do a little split screen so that you can see what's happening on my end, and then I can show what's happening on the Anaconda prompt. So first I'm going to activate my workspace. So I'm going to activate PY Sydney, and then I'm going to run the code. So what we can expect to happen here is once I run the code, it'll be running. We'll know when it starts because my camera will light up, and then it will just run until my face is detected. So I'm going to demonstrate that objects such as myself can be within the region of interest without my face being detected if the camera cannot see my face. So to demonstrate this, I'm going to hold this notebook in front of my face so that there is no face to recognize, to demonstrate that an object won't be detected unless it's a face. So I'm going to hit run on the code. And now as we wait, my camera is just initializing. We'll see how it turns on after about 5 seconds because of the time sleep, and that's just allowing the camera to adjust to the lighting of the room. And then once I see that camera turn on, I'll give it a couple seconds and move around a little bit to demonstrate that as an object is in the region of interest, it still does not begin collecting those images or saving a video until a face is detected. So now my camera has been turned on. We can see that nothing's happened yet because the algorithm is not more than 50% confident that a face is in the region of interest because I'm blocking it with this notebook. Now, as I pull down the notebook and I give peace sign, a person has been detected as seen by the prompt. So as we're waiting here, very similar to the smart doorbell algorithm, 2 images were taken right when I was detected and they were stored as variables. And now we're waiting. I can wave, thumbs up, whatever. We're waiting for a 25-second video, which is the time that I allotted that I want to record its contents. And then once that has been recorded, an email has been sent, and that's how you know that the code is complete. So I'm going to stop the code before it detects my face again. And now I'm going to, first we can look at my files. We enter my files. We can see right now it's 122. So we can open up this video, and we can see the duration is for 25 seconds. This is just me explaining the code, showing what's happening. You can see me talking to the camera, so that can probably get a little confusing. So this is just me explaining my code, showing what's happening. I give the wave here. We can see the thumbs up, all those good things. And yeah, I'll just let this play out for demonstration purposes. And moving forward, we can also check for an email. This is a previous test that I've run. Now, my most recent images, you can see this one is snapped right when I move my face into the region of interest. So now my face has, boom, been exposed, and you know that a face has been detected in the region. So, in summary, I hope you enjoyed this quick little video. Super similar to the smart doorbell detection algorithm. That was a great pipeline, and most of it was the same between both of the codes besides the method of detection and the things that came with that. So for example, since our method of detection didn't really rely on altering the images and comparing pixel by pixel, there was less lines needed in this algorithm. So yeah, I had a lot of fun with this project. I have another video coming up really shortly about facial detection again. So if you're interested in learning a little bit more about this side of Python and my projects, I hope you give my last video a view for this course. So thank you so much for following along with me. I've had a lot of fun doing these, and I hope more personal projects are to come.